Well, good day to all of you. So, today after the basic introduction on the mass transfer processes and also some insight into the equilibrium considerations, it was basically a recap of the thermodynamics course which you had done, I think, in your second year, etc. So, today we are going to take up, as I had already said, we will be taking up each individual process and discussing it in details. Now, since distillation, it is the most widely used separation process in industries. So, first we will be starting with distillation, right. Now, as I had already mentioned that distillation, it is already known to you, this is a process of separating miscible, binary or multi-component mixtures into two or more fractions. It can be two fractions, it can be more than two fractions. So, therefore, it is basically it is the separation of miscible or multi-component mixtures into two or more fractions by utilizing the difference in their volatility. And the equipment, the distillation equipment that we have, as we had already mentioned, that the two phases are first brought into intimate contact. So, therefore, in this case the second phase, which is the vapor phase, if we have a liquid feed, it is a liquid phase if we have the vapor feed, and the second phase has been created from this first phase by transfer of energy. So, therefore, after creation of the two phases, the equipment, it ensures intimate contact between the vapor and liquid phase. When there is an intimate contact, what happens? There is transfer of components between the two phases, and this transfer of component, it occurs by interphase mass transfer, right. So, therefore, in this particular case, the transfer, or rather the mass transfer which occurs, as I had already mentioned, that was interphase mass transfer. As a result of this interphase mass transfer, the vapor phase, it becomes richer in the more volatile components, or in other words, more volatile components, they cross the phase boundary from the liquid and into the vapor phase, and the less volatile components, they cross the boundary from the vapor to the liquid phase. As a result, after the end of the distillation process, what do we get? We get a vapor phase richer in the more volatile component and a liquid phase which is richer in the less volatile component. Now, distillation, it can be of different types, right. It can be a single stage distillation, it can be a multi-stage distillation, it can be a batch process, it can be a continuous process. Now, the most simple equipment of distillation, it is a single stage distillation column, where inside the we have the distillation takes place in a flash drum. We can have a liquid phase or a mixture of vapor and liquid phase. We can also have a vapor phase. Now, what happens in this particular flash drum, the liquid feed or the vapor feed, whatever it is, the liquid or the liquid vapor mixture feed can be introduced. Generally, we denote the feed composition, the feed flow rate as F, and the composition as ZF for each ith component. The reason for selecting it as Z and not X or Y is just to show that the feed can exist in any of the phases. When it is only a liquid phase, naturally ZFI becomes equal to XFI, and when it is only a vapor phase, ZFI becomes equal to YI, right. Now, what happens? Generally the liquid feed, it is passed through a preheater, and from the preheater it gets heated to an extent where it is almost or in saturated conditions, but we try to ensure that the phase separation does not occur here. After that, the feed, it is throttled across a throttling valve, and then after it is throttled and introduced into the flash drum, naturally it is under saturated conditions, and here in the flash drum it separates into two phases, the vapor phase which goes out and the liquid phase which is drawn out from the bottom. The composition of the vapor phase, it is denoted by Y. The composition of the liquid phase, it is denoted by X. This particular process, it is always continuous, and this is the process that we use, right. This is the simplest distillation process. Now, after this distillation process, there is the other process which is there, the next simple process, it is the batch distillation process. Now, let me tell you that batch distillations processes are gaining increasing importance nowadays due to the increasing application of chemical engineering principles in the production of fine chemicals, pharmaceuticals, food industries, etc. So, therefore, if you go in a oil refinery, you will definitely find fractionators, while in these small in these particular places or in these particular industries for small scale production, and it is very important that the product quality is controlled. Under those particular circumstances, we generally go for the batch distillation process. Now, in batch distillation, as it is quite evident, it is a batch process. So, therefore, in its simplest form, what do we have? We have a still. In this particular still, the liquid of known composition is introduced, and then this is heated. Moment it is heated, normally it can be heated either by the introduction of coils, or maybe the vessel can be jacketed, and usually a condensing liquid from maybe some other part of the plant, or maybe a condensing steam is usually used for providing the heat. Now, once it is heated, then naturally what happens? The vapor forms, the vapor, it rises up, it rises through the vapor overhead line, and from the vapor overhead line it goes to the condenser. In the condenser, the vapor is condensed, and then it is collected in the reflux drum, and from the reflux drum we collect the product. It is usually known as a distillate with the composition of Xt, right. And the liquid which initially when we had started, then the liquid flow rate had, it was F, the composition denoted by Xf. At the end, whatever is remaining, that is denoted as B, and the composition of the feed, if it is a multi-component feed, if it is a binary feed, then generally Xd, Xf, Xb, they refer to the more volatile component, the composition of the more volatile component. And if it is a multi-component feed, then for each component we denote the composition of the ith component by a subscript I associated with each particular composition. Now, for a binary mixture, as I have told you that since your the compositions, they refer to the more volatile component. So, naturally it is quite natural that Xd is greater than Xb, and in this particular way we attain the separation. Now, this is the simplest, as I have told you, this is a single stage vapor liquid contacting. In order to understand this better, just I had wanted to show you the process on a thermodynamic plot. Say suppose we have started from this part, we keep on heating it till we reach the saturated conditions. From the saturated conditions, what happens? The vapor forms. This is the liquid feed and its composition is say Xf. This particular plot is definitely for a binary mixture, it is quite evident, otherwise we could not have done it. And this is plotted in terms of the more volatile component. So, rather x, y they correspond to the composition of the more volatile component, and so therefore, moment it reaches the saturation state, what happens? We get the vapor which is in equilibrium with this composition. So, therefore, the vapor which is rising from here, the composition of this vapor is denoted by this particular, say it is y1 for to say Y1A or something. So, the vapor which is rising from here. Then it goes up, it is condensed, and when it condensed, same the composition is the same. So, therefore, what we find is we had started from this particular composition, and the distillate that we have got, that is quite naturally you can see that is richer in the more volatile component. Well, now this is very simple, this is the simplest type, as I have told you, that with a heated still and the condenser which are operating at atmospheric pressure, very simple, but it is very naturally you have already realized the limitations of this. You can very well understand that the maximum separation that we can get from here is the equilibrium composition in equilibrium with the feed composition. And also you know that under practical situations it is going to be lesser than this. Also along with that we know it is fairly expensive. So, therefore, if we want to enhance the distillate composition, or if you want to make the distillate richer in the desired component or the more volatile component, what we can do? The distillate that we have got, that we can redistill it, and moment we repeat the process, what do we get? Again from this liquid we get a vapor which is richer in the more volatile component, and it is in equilibrium with this. Moment we condense this, we find that we have achieved additional enrichment. If we keep on repeating this, then definitely we would get finally a product which will be almost comprising of almost pure more volatile component. So, therefore, redistilling is definitely one particular way by which we can enhance the purity of the distillate. Apart from that, what else we can do to in order to improve the performance? See, it is quite evident that suppose we go for lower and lower pressure. This particular TXY diagram is constructed say at a pressure of 1 atmospheres or 1.5 atmospheres. Suppose we decrease the pressure, what do we find? When we decrease the pressure, firstly is the difference between the bubble point and the dew point increases for any particular composition, or in other words the TXY curve, there is greater gap between them, which shows that it is quite evident that in this particular case the separation that we get, and at a lower pressure we get much more separation. So, definitely we can operate at a lower pressure and improve the performance of the batch distillation. But in this case you have to remember one thing. Suppose we go for a very low pressure, say for a pressure lower than say 0.1 kg per centimeter square absolute. What do we find? We find that under that condition the still it has to be operated under vacuum. Usually the vacuum it is created by an ejector which consumes steam, and we find that the steam consumption it increases significantly when we go for pressures much very low pressures, or rather pressures much lower than 0.1 kg per centimeter square, and under that condition this option becomes uneconomical, right. So, under that condition, see, as I have told you that nowadays batch distillation is gaining in importance. So, therefore, for increasing or rather improving the performance, what we can do? We can opt for a multi-stage batch distillation column. Usually this is opted, as I have already mentioned, when the required product purity is higher than that which can be attained with a single stage. In a single stage, the best that we can attain is in equilibrium with the feed composition. If we want the product purity higher than that, then definitely we have to opt for a multi-stage, just as the way I was showing you the redistillation. Also the way I have shown you that if the difference between the Tx and Ty curve is very close, or in other words for low relative volatility, a thumb rule is for alpha less than 3. For these particular systems we opt for a multi-stage batch distillation. What is this multi-stage? We still have this still. Over this particular still, what we have is we just put a column over this particular still, right. Now, in this particular this is a tower or a column in whatever way you tell it. Now, here we can either have trays or we can have packings. Normally, this column is not very big, and usually for such a column we either use sieve trays or in other words we can also use the packed bed here. The details of the sieve trays, packed bed etc., they will be discussed after we finish the mass transfer operations. Then in a consolidated form we are going to discuss the different tray towers, and there you will be getting more idea regarding these two, right. So, therefore, what happens, it is the same thing, steam is there, steam provides the heat and then the vapor it rises from here, the liquid remains here. Vapor now what it does, it rises to the tower. It rises to the tower, it reaches the condenser. From the condenser it gets condensed. Then the condensed liquid, it comes and it is collected in the accumulator, or in other words it is known as the reflux drum. Now, from the accumulator, then in that case we get one product which is definitely richer in the more volatile component. Some amount of this particular product we take it out, say the flow rate is D, or rather the yield is D and the composition is XD. Some portion of this product we recirculate it back into the column. This particular portion is known as the reflux. Now, this reflux is introduced. What is this reflux? It is richer in the more volatile component. So, definitely when the vapor is flowing up and it comes in contact with the reflux, then what happens? There is additional mass transfer between the reflux and the vapor. During this, the reflux is a liquid and the vapor is a vapor. So, when there is an additional mass transfer, what happens? From the reflux, more volatile components diffuse in the vapor phase. From the vapor, less volatile components come into the liquid phase. As a result, we get enhanced enrichment of the vapor phase. And in this particular process, just by the repeated distillation that I have shown you, due to this additional enrichment, we can get much better or rather much better product quality from the multi-stage batch distillation as compared to the single stage batch distillation. Now, usually these are small scale units, and for most cases we find that the tower, it is just mounted directly on the chart stills. Vapor, it rises by gravity, and generally the condenser and accumulator, they are kept at such an elevation that the liquid, it is reintroduced into the tower and it falls again by gravity. It can also happen for bigger units that the tower, it is just placed next to the still, but at an appropriate elevation such that gravity flow of liquid from the tower bottom to the still can happen. So, this is the other distillation, or rather the other distillation process that is also used. Now, the most common process, as I have told you, are fractionators. These fractionators, they are the most common and they are continuous processes. Here there is a cascade of multiple stages that we had already discussed. Now, this cascade of multiple stages, they are provided either by trays, usually distillation, big distillation columns whose diameters are greater than 1 meter or so, they are provided with trays. And just as I have mentioned, for improving the gas vapor liquid mass transfer, for ensuring smaller bubbles of the vapor, the trays, they are perforated, and on the perforations there can be different attachments or accessories like bubble caps, valve trays, etc. So that the mass transfer is enhanced. Now, in this particular column, the feed is usually introduced in a central portion which is usually known as the feed tray. For a packed column, this is known as a feed zone. Now, once the feed is introduced, the feed, it can be, here we can have a liquid feed, we can have a vapor feed, we can also have a vapor liquid mixture feed. Now, once it is introduced, what happens? The vapor part, it rises up. Just like I have discussed in the multi-stage batch distillation, vapor rises through the overhead vapor line, it reaches the condenser. In the condenser, cooling occurs, vapor gets condensed and then it collects in the reflux drum, or it is also known as the accumulator. From the reflux drum, as I have said, a part of the product, it is drawn out, it is known as the distillate, composition denoted by XD. Part of it, it is reintroduced into the column as reflux. Definitely reflux, it is denoted as R. The composition, you know, it is the same composition. When this reflux is introduced, then again this reflux, it comes in contact with the rising vapor and it enriches the vapor. So, therefore, by this particular process, we get high purity of the product. So, the section above the feed where enrichment of vapor occurs, this is known as the enrichment section. Where the reflux meets the counter in a counter current fashion, the vapor and enrichment occurs. Now, what happens below the feed tray? Here the liquid comes down. This liquid, if it has to be enriched, it has to come in contact with a counter flowing vapor in this case. So, from where is this vapor generated? The liquid, it flows down, it comes to the bottommost tray. From the bottommost tray, it is withdrawn and then it is sent into a reboiler. What does the reboiler do? The reboiler, it partially vaporizes the liquid which comes, and we can use different sort of an heating medium. It is basically a shell and tube heat exchanger. There can be different designs of the reboiler, which we will be dealing in details when we discuss the distillation column. We can have thermosiphon reboilers, we can have kettle type reboilers, and in this reboiler what happens? Vapor is generated. That vapor, it is again reintroduced into the column just below the bottom tray and just above the liquid hold up in the bottom of the tray. So, this vapor, what it does? This vapor, it rises up and it meets the liquid which is falling down. So, therefore, there is during this counter current flow, there is again mass transfer between the vapor and the liquid, and as a result more volatile components, they move from the liquid to the vapor phase. Less volatile components, they move from the vapor to the liquid phase, and as a result mass transfer occurs. Vapor becomes richer in the more volatile component, then it rises up. Then in the enrichment section, the enrichment of vapor with respect to the more volatile component continues as it comes in contact with the reflux, and finally with all this enrichment we get an almost pure product from the feed that we have started. And what will be the purity that we will get from the feed composition and the flow rate with which we have started? That we get, or rather we can achieve that by deciding upon the number of stages in the column. So, depending upon the purity, we decide the number of stages. Initial calculations assume that on each tray the vapor and liquid which are leaving, they are in equilibrium. That means, we perform the calculations assuming ideal contacting trays, and we knowing fully well that ideal contact or equilibrium trays do not exist. So, after we have found out the number of ideal trays, then we consider a fractional overall efficiency, and we then compute to find out the actual number of trays which will be required to effect this particular separation. So, therefore, this section, the section where the vapor is stripped off of its less volatile components, this section is known as the stripping section. So, therefore, the distillation column, the fractionator column in its most simple form, this has got a feed tray, enrichment section above this, stripping section below this, and then the liquid which enriches the vapor, it is supplied from the vapor which is condensed, and then it is collected and in the reflux drum, and this is provided as a reflux. In the same way, the vapor which forms in the reboiler, that is once more introduced here, and that also provides the additional separation. Now, it is important for you to remember that while mostly we operate with total condensers. What does total condenser means? Total condenser means whatever vapor comes, usually the entire vapor, it is condensed into the liquid, part of which is sent as reflux, part of which is withdrawn as distillate. On the other hand, in the reboiler we find that we undergo partial vaporization just to obtain the vapor which is required to be introduced in the distillation column. The remaining portion of it, it is withdrawn as a bottoms product, flow rate B, and the bottom composition as XB. So, therefore, what do we find? That the reboiler, that also serves as a partial vaporization unit, where the liquid is partially vaporized, the ensuring vapor and the liquid are in contact, the vapor is introduced back into the column, the liquid part is withdrawn out. So, therefore, the reboiler also acts as a single stage, and therefore, when you are calculating the number of ideal stages, we have to remember that the reboiler also accounts for one particular stage here. So, therefore, just to conclude, we find that this is just a summary of what I have said. There is not much for me to discuss here. We have found out that fractionator, one thing I forgot to say, the reboiled stripper is nothing. In the reboiled stripper, we do not have the enrichment section. Feed is introduced from the top and then it flows down. So, we usually have a stripping section. So, for all these cases, the fractionator, the reboiled stripper, the flash distillation, they are continuous processes, and fractionator, reboiled stripper, multi-stage distillation column, they have multiple stages. Flash and the simplest batch distillation, they have one stage each. While we discuss the batch distillation, I will be rather you will understand that actually a single stage batch distillation, it performs an enrichment of slightly greater than a single stage, because when the vapor rises, it comes in contact with the cool part above the still, and there some amount of vapor condenses and falls down. So, therefore, the enrichment is almost equivalent to 1.1 stage. Feed entry location, there is nothing to say. Fractionator, you have already found that it is in between the top and bottom stage. In the flash distillation, definitely it is introduced into the flash drum, and it will be introduced in the zone just above the liquid level in the flash drum. In batch distillation, definitely the feed is introduced at the still. The liquid conditions which are there, the feed conditions which are there in different distillation types, it is mentioned here. We have already discussed these things, there is nothing for us to say. We require a top reflux whenever we want an enrichment, and a vapor reflux for additional enrichment. Both these type of refluxes, they are there only in a fractionator, and naturally, therefore, in a fractionator we get the maximum amount of enrichment or maximum amount of separation, and therefore, a fractionator is the most commonly used distillation column in industries. And again, as I have told you that very recently batch distillation units are, of course, for that case I would say the multi-stage batch distillation units, they are being increasingly used in pharmaceuticals, cosmetics, food products, fine chemicals and such other industries. Now, in the next class what we plan to do is that once you have got an overview of the different distillation processes, what I plan is that we will take up each distillation individually and we will be discussing them. So, first we will be taking up flash distillation, we will be discussing about the simple technique of flash distillation and how to design the flash drum, what are the inputs we require, what are the outputs we require, what are the controls which are required for a distillation drum. Although it is a very simple equipment, you will find that there are certain details which need to be considered. After flash distillation, then we are going to discuss the fractionator, and after the fractionator we will be discussing single stage batch distillation, and we will also be touching upon multi-stage batch distillation columns or batch distillation still along with the column. So, with this we end here. In the next class we go ahead with our discussion on the design of a flash drum, what are the things that have to be considered and how we proceed with it. Thank you very much.